On your notes, please title it, write down the essential question, what does Newton's third law state and how does it apply to real life, and then leave a space at the bottom to answer this essential question once you finish your notes. If you are in Avid and you want to create a question column here so that you can use these for your Avid notes as well, you are more than welcome, but you do not have to for my class. Sir Isaac Newton said that forces always come in pairs, and he called these pairs action and reaction force pairs. So imagine that somebody is pushing on a box. What Newton said was, if you touch a box, you can actually feel the box touching you back. So what he's saying is that there is a reaction from the box pushing back on you. Newton's third law of motion states that for every action force, there is always an equal and opposite reaction force. So here are two really great examples of that. Let's say a rocket ship is sitting on the launch pad. Well, the force from that rocket, the fuel, the explosion, all of that is going down towards the ground. Now, when that reaction or action happens, there is a reaction and the rocket then goes up. The force goes down, but there's also a force going up. Let's say you're at a baseball game and you see that the pitch gets thrown and the bat hits the ball. You hear the sound of the ball contacting with the bat because there are two forces that are happening right here. There's a force from the ball that, let's say it's hitting with a force of 70 newtons. Well, the bat then is hitting back on the ball with the exact same amount of force. They are in opposite directions, but they hit with the same amount of force. Isaac Newton said that for every action, there's an equal and opposite reaction. Here's a short little video clip to exemplify then. Why is it if every force, action, and reaction are equal, then how does anything actually move? Watch this.
Zoe, watch out! Ouch! Hey, are you okay?
Yeah. Oh, hard bench. I guess I wasn't looking.
Now that's what I call action and reaction.
Action and what?
Action and reaction. It's Newton's third law of motion.
What?
You know Isaac Newton, the gravity guy? He realized that for every action there's an equal and opposite reaction.
Like, if I run into you, you run into me at the same time?
Pretty much, but there's more to it. Okay, so when you bumped into me, you applied force or pressure against me.
Yeah, sorry about that.
According to Newton's law, my body pressed back against you with the same force.
Come on.
We both felt the same force because the forces from our bodies pressed in opposite directions.
Yeah, but if we hit with the same force, how come only I got knocked down?
Good question, champ. It's all a question of size and weight, or mass. First of all, who's bigger and heavier, you or me?
Is that a trick question? You, obviously.
Well, according to Newton, when two objects with different mass collide, they'll accelerate at different rates.
Accelerate?
Change their speed and direction.
So, even though their forces are the same, one will accelerate more than the other?
You got it. The smaller object will accelerate more.
Smaller. That would be me. So I fell and you didn't.
Hey, come to think of it, the same thing happened with you and my soccer ball. You hit each other with the same force, but the soccer ball went flying.
I got it now. Because my mass was bigger, the ball accelerated more. How about when a baseball bat hits a ball?
Yep, both objects hit each other with equal force in different directions. The ball goes flying because it's smaller. The way the bat is moving when it hits can make the ball go in different directions.
And what happens when two things that are the same mass collide? Like two pool balls?
Well, what do you think?
Well, they hit each other with the same force. And the forces press in different directions, so they have the same acceleration?
Yeah.
Wow, this action-reaction thing is a little complicated, but I think I've got it. Newton's third law says that for every action, there's an equal and opposite reaction. That means that when two things collide, they press with the same force, in opposite directions. That's why you and I both felt it when we bumped into each other. And when the objects have different mass, like we do, they'll also have different acceleration. The smaller object, me in this case, will speed up or accelerate more.
And she scores. Now that's what I call a smart reaction.
What can I say? I'm just a genius in full force.
That was an incredible video. I hope you enjoyed it. But anyway, however cheesy that cartoon was, I thought it really gave a good example for you to see why things move, even though there are equal forces acting on them. Now, I'm going to give you a few examples. I want you to write about and draw one of them that makes the most sense for you. So let's say you have a hammer that's hitting a nail. What's happening here is that when the hammer exerts a force on the nail is exerting or putting a force back on the hammer. So you can hear a hammer hitting a nail and a nail hitting a hammer back. It's a really loud sound showing that there are two forces happening at the same time. Now, the reason why the nail is the one that usually moves is because the nail and the hammer have different masses. So since they have different masses, they have different accelerations, and that nail is the one that's going to move more. Here's another example you could write about. Everybody has stubbed their toe at some point in their life, and the reason why it hurts is because if we kick a table, that's our action force, but it hurts because the table is actually, in a way, kicking back. It's a reaction back from the table. Now, the table and the man in this case have different masses, and so usually then the table doesn't move. They're going to have different accelerations. Here's one final example. Let's say you have a girl that's pulling a backpack across the sidewalk. Now she may feel a resistance from that backpack pulling in the opposite direction of her. It's pulling against her. She has an action force pulling this way. The reaction force would be equal but opposite. But because the girl and the backpack have different masses, they're going to have different accelerations. That backpack is the one that's going to move because the girl has more mass. Here's a different kind of force that I want to talk about and I want you to write about in your notes. It's a force called the centripetal force. This is a force that is constantly changing the direction of an object's motion, causing it to move in a circle. This centripetal force points toward the center of the circle. According to Newton's third law of motion, we always need to know the direction of the force. The direction of the force is very important. So let's say that there's this woman and she has a ball on a string. If she puts her hand in the center of the circle and whips that string around, then the ball is going to be traveling in a circle. Her hand is in the middle of the circle. She is standing in the middle of the circle, showing that the centripetal force is pointing toward the center of the circle. That's where the force is coming from. The same thing happens on a roller coaster. If a roller coaster has a loop, there is a centripetal force pointing towards the center of that circle. Now, how does this apply to Newton's third law of motion? Well, if the centripetal force is pointing toward the center of the circle, then there's a reaction force then pointing away from the circle and keeping the roller coaster against the track so it doesn't fall toward the center of the circle. Now, there are actually a few different forces in play here. Inertia is keeping the object wanting to go in a straight line, but it doesn't because of the track, and then it wants to go that way, but the track keeps curving it all the way around. So there are a few forces in action here, but the centripetal force is the force that is pointing toward the center of the circle, creating the circle, and then there is a reaction force that's moving against the centripetal force that keeps the car of the roller coaster against the track. So once you've taken these notes, please go back, read, and review so that you can answer the essential question at the bottom of your notes.